Okay, hi everyone. So we're first going to start. So this is Unit 5, Chapter 18. Okay, so sampling distribution. So Chapter 18 was just kind of a brief intro. So the central limiting theorem is basically saying when you increase the sample size, the sampling distribution will become more normal. Now Chapter 19, 1 proportion z interval. So remember, proportions use z as your test statistic. For t-test, it's for means, and then chi-squared. So proportions, you want to estimate plus or minus margin of error always for confidence intervals. So you're going to do p hat plus or minus the test statistic, the critical value, z star times square root p hat q hat over n, and this is the standard error of p hat. Okay, so this is the general formula, and then this is how you do it on a graphing calculator. So you go to stat test A, so go down until you see A, 1 proportion z interval. In this example, it's 54 is the x value, 104 is the sample, and confidence interval is 0.95, and then calculate, and you'll get this as a confidence interval. So that's how you use your graphing calculator. And the conditions for a 1 proportion z interval is independence assumption, and then the random and 10% condition, and then success failure to prove that the sample size is large enough to do a normal model. Okay, and then interpreting confidence level. So this is an example. If we repeated this process many times, we would expect 95% of all the samples to have a confidence interval that contains a true percent of, for example, all cats in the US affected. So this is just an example, but that's usually the format for interpreting the confidence level. And we'll talk about interpreting the confidence interval later. But before doing these type of problems, you always want to think, is it one sample, two sample, proportion or mean, confidence interval or test? So you always want to identify the test first before you do any of this. Okay, now chapter 20, 1 proportion z, interpreting confidence interval. Example is we are 95% confident that between 5% and 10% of all cats in the US has the disease. So you're saying you're 95% confident that between the confidence interval of the whole population. So in this example, it's all the cats in the US is the population. Okay, chapter 20, 1 proportion z-test. So you can remember as HAMC, hypothesis, assumptions, mechanics, and conclusion. So hypothesis. In the hypothesis, you want to write the null hypothesis, the alternate hypothesis, and for the alternate hypothesis, you have to think, is it one-sided or two-sided? So one-sided is if the problem's like less than or greater than, and two-sided is if you see different. And you also want to define P. So you need 3 things in the hypothesis: null, alternate, and define P. So this is an example. P equals the proportion of candidates who pass the driving test. And P is the population parameter. Okay, and then assumptions is next. In a 1 proportion z-test, you need 2 main ones: the independence assumption, and then in the independent assumption, you want randomly selected sample and 10% condition. And remember, it's randomly selected sample unless it's an experiment. Then you, instead of randomly selected, you want randomly assigned to treatment. So that's only if it's an experiment though. And success failure, again, is the sample size large enough, NPO. So make sure it's not NP hat, it's NPO. So in this example, it'd be 90 times 0.8 is greater than or equal to 10, 90 times 0.2 is greater than or equal to 10. And then you'll just write a statement that says, Since the conditions are met, I'll do one proportion z-test. And if the conditions are not met, then you'll say, I'll proceed with caution. So in the assumptions category, you need to make sure you have independence and success failure, and you need to name the test. Again, this is a one proportion z-test. Okay, now on to mechanics. So this is where all the math is. So you first need to draw a normal model. So the center is 0.8, which is the P, the null hypothesis, and then P hat is over here. In this example, it's 0.68. So you first find the standard deviation, and this is the formula for the standard deviation of P hat. You do P times Q over N, and then you do Z equals the 0.68 minus 0.8 over standard deviation. And you'll actually not use P hat that much for the calculations until really this part. So most of the times, with the conditions and with finding standard deviation, you really don't need P hat. P hat is only for finding the z-score. And then the p-value of when the z-score is less than negative 2.86 is 0.0019. So you'd write and then the conclusion. But again, let me go to mechanics. So mechanics, you need to draw the normal model, calculate the standard deviation, write the test statistic, which is in this case the z-score, and the p-value. In conclusion, you'll write whether you reject or fail to reject, and context. So example is, since a p-value of 0.0019 is low, I reject the null hypothesis. There is strong evidence that the passing rate for teens taking the driving test is lower than the DMV reported. I would expect, and then you don't have to say this part, but you can say, I would expect to see a sample proportion of 0.19% of the time, which is very unlikely. And on the graphing calculator, you go to stat test, and then you want, again, this is a one proportion z-test, so you go to 5, one proportion z-test, and then you go P is 0.8, and then the X is 54, N is 104. It's different, so it's not equal. Calculate, and you'll get, when you calculate the Z and the P, the z-score and the p-value. So, okay, next we're going to do chapter 21, which is more about more building off of chapter 20. So p-value is conditional probability. It's a probability of getting the observed proportion or more extreme given the hypothesis, the null hypothesis is true. Again, p-value is conditional probability. Type 1 error is the null hypothesis is true, but we mistakenly reject it. Type 2 error is the null hypothesis is false, but we fail to reject it. So one way to remember this is type 1 is first, so the null hypothesis is true. And then alpha is the probability of type 1 error. Beta is the probability of type 2 error. And alpha is also the significance level. So if the p-value is lower than alpha, then you reject the null hypothesis. And then power is 1 minus beta, or 1 minus the probability of the type 2 error. And power is when you correctly reject the null hypothesis. So that is good. So you want more power. So when alpha increases, you can look at this picture here. When alpha increases, beta decreases. And when beta decreases, power increases. But to reduce all the errors and to increase power, you can increase the sample size. So that's why increasing sample size is good. Okay, now chapter 22, two proportion z intervals and z-tests. So, two proportion z interval first. I didn't write out a full test, a full interval, but basically what you want to do first is list out everything you're given, list out your n. So in this case, it's boys versus girls. So I have a p hat for boys, I have a n for boys, and I also have x for boys, and same thing for girls. And then after you write down everything, you want the conditions. So there aren't hypotheses for this, but the conditions are the same thing: independence and success failure. But now that you have two proportions, you have two samples now. So it's also independent groups. So instead of two main conditions, you have three. So independence, because random and 10% condition. Independent groups is saying the two groups are independent of each other, and the reason why is often because they're randomly selected samples. And then success failure is, again, sample size large enough, and p hat is greater than or equal to 10, and q hat is greater than or equal to 10. Okay, after the conditions are met, you'll say, since the conditions are met, I'll do a 2 proportion z interval. And that's the math here to find the standard error of p hat girls minus p hat boys. You do p hat, so this is in the blue, this is the general formula, p hat q hat over n1, so that's n plus p2, p hat 2, q hat 2 over n2, and then square root that. And then you got standard error. So then p hat the difference, so p hat difference is p hat girls minus p hat boys. So in this example, let me find it. So p hat boys is 0.57. So and then girls is 0.7. So it's 0.7 minus 0.57 is 0.13. So the confidence interval is 0.13 plus or minus z star. So the critical value of 95% confidence is 1.96. And then you'll get this as your result. And then we are 95% confident that among 15 to 17-year-old teens, the proportion of girls with online profiles is between 4.6 and 21.4 percentage points higher than the boys. I forgot to write higher for some reason, but higher. So that's the difference. The confidence interval, this is saying, because you're doing girls minus boys, it's like 4.6 percentage points and 21.4 percentage points higher. Okay, so now we're going to do 2 proportion z test. So 2 proportion z test is the same thing as pooling. And with pooling, basically, it's pretty much the same, except except over here, you can see you kind of just add the 2 and then you add the 2 ends. So you add the 2 y's and you add the 2 ends and then you divide them, and then that is like your p hat pooled. So then in the standard error, you'll do the same thing. So notice how this denominator is same because p hat pooled equals 0.37. So it's 0.37 times 0.63 over n1 plus 0.37 times 0.63 over n2. But let's go back to here. So this example is, are snoring rates of the 2 age groups different? When you see different, you think two-sided. So in your null hypothesis, remember you need 3 things, and I actually did not mention that. Let me actually write that. So you want to write the null hypothesis, the alternate hypothesis, and define p old and p young. So those are the 3 things you need. And then you have the assumptions, the same thing as the confidence intervals and tests always have the same assumptions. So 3 main assumptions. And then the statement, which I also did not write. Sorry about this. So you'd write, since the conditions are met, I'll do a blank test in this case. Since the conditions are met, I won't write out all of it. I'll do a 2 proportion z-test. This is why you should always check your work. Okay, and then now the calculations and mechanics. So you can use your graphing calculator. If you go to 6 2 proportion z-test, it'll pull directly for you. But again, like the p-hat pool, you just add them and use the p-hat pool, and then do normal model. And since this is two-sided, because it says different, not less than or greater than, you want to do 2 times the p-value. And in this example, you get a very low p-value, so you reject the null hypothesis. Okay, thanks so much for watching. I'm going to make another video like in 3 minutes. I'm going to go live for just reviewing the formula sheet. It'll be extremely quick video, but I think it's very important because the formula sheet, you'll have it during the exam. Okay, thanks for watching. Bye.